Good morning, everyone. It's finally time for our new packet. Hopefully, you guys all did great on your Unit 6 test yesterday and on Friday. Today, we're going to get started with our new information. Our new unit is Unit 7. These are transformations. Looking through our packet like we typically always will do. You have your standards at the beginning. We have all of our new vocab listed here. Go ahead and read through those, see if there's any that you guys have questions on. We have our pacing guide. Notice on our pacing guide, we have one quiz down here, and then we do have a test. This is a typical size unit. We have about, looks like 8 different lessons in this unit. So let's go ahead and get started. Your cheat sheet is next. But here we go. We'll get right into today's lesson. All right, we're talking about the basics of transformations today. To transform a shape or a figure means to change it. In general, we can change the size, location, and direction. So these are the 3 things. We change the size, the location, and the direction of the figure. The pre-image and the image. The figure before, so this is important right here, the figure before a transformation is called the pre-image. Or the original figure. After a transformation, the new figure, so the new one, is always called the image. If the pre-image were labeled A, then the image would be labeled A prime. So again, the pre-image is always A, or a capital letter, and the image is always prime. It has that little apostrophe right there. It's always pronounced A prime. All right, the table below gives an overview of the different types of transformations. We're going to label the pre-image and the image in each of these examples and then list any keywords for the transformations. All right, this first one is called a translation. Here's our translation. Okay, if you notice, this is our pre-image, so this is the original. And all we did is we slid this down. So the key word is to slide. So we took our pre-image and we slid it, and now we have our image down here. And you notice that it's denoted with a little prime hashtag. The next one is a reflection. Okay. So note right here, this is the pre-image. This is our image. What we did in this one is we just took it and we took the original shape and flipped it over. So our key word this time is going to be flip. The next one is a rotation. Here is our pre-image. Here is our image. You can see, so the key word, you're just taking it and now you are turning. Okay, and then in our last one here, this is called a dilation. This one is our image. This is our pre-image. Here is our image, and this is to enlarge, or it could be to reduce. So now we're going to go back and take a look at these. It also said to label the pre-image and the image. So in the first one, this is our pre-image. This would be the image. In the second one, this is our pre-image. This is our image. Over here, this one is the pre-image, and this is our image. And down here, this is the pre-image before we did anything. This is what we did after the image. So again, these are the 4 basic transformations we're going to be concentrating on in this unit. The translations are just taking a shape and sliding it. Reflections are taking a shape and just flipping it over somehow. A rotation is just turning it a certain number of degrees. And a dilation is making something either much bigger or much larger. No, smaller. Can't have the same. All right. Where do you see these in the real world? So a translation, where something is just sliding. This could be like a conveyor belt. This is something where you could see something where you have a translation. You place something on there, and it just slides on down. A reflection, this could be any type of water. If you have a pond or something and you're looking into it, you can see a reflection of yourself. So this is when you have water and you see those reflections in the water. That's one real world situation where you could see that. A rotation, how about a wheel on a tire? Or a wheel somewhere. Those are rotating and going in circles. And dilations, usually your pupils in your eyes. Anytime you go to the eye doctor, they quite often will dilate your eyes, meaning they make them bigger or smaller so that you can see a difference. All right, so let's continue on. And the next one, we're going to talk about congruence and orientation. Congruence refers to whether the pre-image and the image have the exact same size and shape. The orientation of the figure refers to whether the pre-image and the image are facing the same direction. So facing the same direction is important on the coordinate plane. The orientation of the vertices refers to the order in which the vertices are labeled. So the order in which the vertices are labeled. And they're either going to be going clockwise or counterclockwise. Okay, so in the next 4, we are going to label what type of transformation is shown first. Then we're going to state if there appears to be congruence between the pre-image and the image. And then we're also going to take a look at the type of orientation, if it changed or if it stayed the same. So first of all, if we have this one, this is our pre-image because you don't have the hash marks. Now if you take a look over here, it looks like we flipped it over or we reflected it. So I'm going to say this is a reflection. Okay, congruence. Okay, is it still the exact same shape in the exact same size? Yep, it is. Same shape, same size. Now, the orientation of the figure. When it says the orientation of the figure, this means are the pre-image and the image facing the same direction, or did it change? So if you look at this one, is this still facing the same direction? No, it's not, because when they flipped it over, now it's facing a different. So this changed. The figure changed. Now it says the orientation of the vertices, are they still going in the same direction? So this is going like A, B, C. This is going clockwise. Now A, B, C is going counterclockwise, so it's going the opposite. So A, B, C is going that way. So the orientation of the vertices has also changed. Again, you just look at the vertices. So because A, B, C was going clockwise in the original figure, in the new figure it's going counterclockwise. That's why we're saying changed. Okay? And the way the figure is facing, if this was the front, now it's on the other side. So it has changed as well. In our next one, this is our pre-image. This is our image. It looks like we just took it and we slid it over. Because it was a slide, this is known as a translation. Is it still the exact same size, exact same shape? Yep. So the congruency is the same. The orientation. Okay, so is it still facing the same direction? Is this still the front? It hasn't changed at all, so that stays the same. And the orientation of the vertices, if I go D, E, F, it's still in the same clockwise order, so that has stayed the same. Going on to our next one. We have a big one on the outside, which is the new one, and the original was the smaller one. So because this is either reduced or enlarged, this is called a dilation. Is it still congruent? Meaning, are direction? So that has stayed the same as well. And our last one that we have right here, we're just taking the original figure and we're turning it. Because it is a turn, this is called a rotation. Is it still the exact same shape, exact same size? Yep, that is true. What about the figure? Is it still facing the same direction? It's facing a different direction now. So now it was facing this way, now it's facing a different, so the direction has changed. And if you look at the orientation of the vertices, they are still going in the same direction clockwise. It didn't switch to counterclockwise, so that stays the same. So looking at these four, you will notice dilation is the only one that does not remain congruent. It means it doesn't change the size of the shape. All the other ones, they all stay the same shape and same size. Now sometimes the orientation of the vertices and the figure changes. You'll just have to look back at this as a reference if you have questions. Okay. Liv and Hassan graph the transformation shown below, and then in questions 5 through 10, record which graph meets the given criteria by writing Liv, Hassan, both, or neither. All right, which one of these represents a reflection? So a reflection, you just flipped it over. I would say that would be Hassan. The image is in quadrant 1. Well, remember, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So the image, which one of these is an image? It's the one that doesn't have, or that has the hash marks, so it would be Liv right here. Preserved congruence, meaning they are still the same shape and the same size. They both are. They are both still the same shape and the same size. Change the orientation of the figure. So if I look at the figure, I have RST going clockwise, but now I have RTS, so it has switched. So over here, Hassan has switched. Let's take a look at Liv. NOPM, NOPM, still going in the same direction, so hers is fine. Which one changed the orientation of the vertices? Same thing. Hassan is the only one that changed. Changed the size of the figure? Neither one. They are both exactly the same still. The same size. Alright, that is the basics of our transformation so far. That's just introducing you to them. Today what you're going to do is you have this for homework tonight. It says students were asked to create true statements about transformations. Circle the names of the students who correctly completed the task. Then unscramble the underlined letters to answer the riddle. So for the names that you end up circling, you take those letters, unscramble them, and try to answer the question down at the bottom. All right, that is your homework for tonight. good luck.